Okay, thank you. I think that we can start since we have quite a packed agenda. So welcome to the webinar, The Hydrogen Revolution, Social and Technical Aspects for a Sustainable Transition Towards Hydrogen Economy, which is brought to you by the Horizon Europe project HYPOP, Hydrogen Public Opinion and Acceptance. I'm Ilaria Schiavi and I am the coordinator of the project. Without further ado, I leave the floor to my colleague, Marianna Franchino, who will illustrate the project and also let you know about the way you can engage with us throughout this workshop.
Yes, thank you, Ilaria, for the introduction. Hope you can see correctly my screen. So, good morning, everyone. And I'm Marianna Franchino. I work in Environment Park and support Ilaria in the coordination of the project. Just few instructions for this workshop. We would like to be a bit interactive in this session. So we have prepared a space in the Slido platform, a space for a HYPOP project and this workshop. So you can use the platform and go to the website slido.com or scan directly this QR code and insert the code that you see in my slide. And you can use this platform to make questions. There will be a session at the end of the workshop to discuss and answer to your questions, but while we are present, you are able to write everything you want. We will also use this website to engage you with some quiz and questions for you. So I will just introduce you our project HYPOP. HYPOP is the Hydrogen Public Opinion and Acceptance project funded by the Clean Hydrogen Partnership. Our objective is to raise public awareness and trust towards hydrogen technologies, and we do it following some main activities. So we are preparing some guidelines and good practices that will be available at the end of the project and will be used to engage citizens, but also consumers and stakeholders. We also are focused on the creation of a social platform to collect communication material, but especially to create a network of projects, hydrogen projects, and to show what are the results and the potentialities of the hydrogen technologies. And another activities is also the definition of social, economic, and environmental indicators coming from the social life cycle assessment of the hydrogen technologies to increase the public acceptance. Our project also focuses on two main hydrogen applications, residential and mobility. So here you can see our consortium. We are 4 hydrogen clusters and 3 research organizations, but also 1 agency that has a role of strategic communication and stakeholder engagement specialist. So what are the steps of our project? There are 3 main steps. The first one is the analysis. We focus on 2 types of analysis, a public understanding of the hydrogen technologies to understand the hydrogen public opinion and acceptance, but also we focus on the other side on a technical aspect. So we analyze what are the technical requirements in terms of permitting, safety, and certification of the product relating to the hydrogen technologies installations. This is our first step and also our first year of project. We have concluded this first analysis. We are now going towards the second step that is about engagement and consultation. So we mainly will organize a workshop and social and raising a campaign on social media in order to understand with our target group that are both citizens and stakeholders, technical stakeholders, how to overcome some barriers and other aspects in order to increase the public acceptance of the hydrogen technologies and support the deployment of the hydrogen economy itself. So we will conclude with the third step, which is the publication of guideline and best practices on how to best involve citizens, but also public stakeholders. And we will also, as I said before, develop social life cycle assessment indicators and communication kit to support the public engagement. So talking about engagement, we would like to start to engage you with the first question. So here you can use Slido. You can see here the website and the code to use. And the first question is, based on your experience, which factors mainly influence the public opinion about hydrogen technologies? You can answer with 2 or 3 words, and we will build together a word cloud that we will comment later on. So, okay, I think you can answer. I can give you some times to answer, and I go ahead with my presentation. So I was saying engagement about target groups. What are our target groups? We talk with both citizens and also stakeholders. So we think that it's important and complementary to involve both of these 2 target groups because, of course, the hydrogen acceptance and deployment of the hydrogen technologies comes from both the citizens and their public acceptance, but also from the overall installation finalization of the technologies. So we speak with first responders, permitting entities, but also certification bodies and decision makers. And as you can see here, we perform 2 types of analysis, a social and a technical one. I will not go much detail in these slides because you will see later from my colleague what are the specific results that we have achieved in this first year of project. But about the social analysis, what we did is a first research about the hydrogen implementation in different European countries. And also the understanding of the public opinion coming from the results of European surveys, and also an analysis of social media behavior from people. So we try to understand what are the engagement activities and action that there are now present in Europe. And so we would like also to use this workshop to understand what is your experience. So here we come with the second question. Have you heard about public engagement activities with citizens and users? So if you enter on Slido, you can see different options. You can select Live and Lab, public consultation, or communication campaigns, etc. But you can also express your position, and so maybe you have never seen this kind of activity. Okay, so on the other side, I was saying we made and we are still working on another type of analysis regarding the permitting, safety, and certification requirements. So we get in touch with a lot of demo projects, but also hydrogen valleys all over Europe to understand the state of the art of the stakeholders requirements, but also the gaps and barriers and the best practices from other countries. And after this first step, we will perform some engagement activities. Basically, there will be 2 types of co-creation workshops targeted to our stakeholders. So there will be a type of workshop to engage the public and the other type to engage the stakeholders. So we will work with experts, with technical experts regarding the permitting safety. We will talk with hydrogen associations or decision makers to understand this type of topic and requirements. And we will hand, as I said before, with the realization of final guideline and good practices for improve the hydrogen acceptance, and this will be supported also by social life cycle assessment indicators. Another important activity is that we are working to create a web platform that will be a place to collect and to give visibility to the hydrogen projects, but also with other entities that work with the hydrogen technologies. So here you can see an example coming from our advisory board and the projects and organization that we get in touch during this first year. But of course, we would like also to you to join us to make collaborations, but also to share the results of your project. So we are working on this. You will see in a few weeks the first web platform with this information. And so again, you can join us. You can scan how you can get in touch with us. You can write directly to us, but you can also join us through the specific session in our website, the Join Our Community. You can scan the QR code that you can find here, or just go directly to our website. You will be just informed about our action, the co-creation workshops that will come later, but also, as I said, we can collaborate together to the hydrogen acceptance. So that's all for my side. I leave my colleague that will present the project.
Thank you very much, Marianna. So you will hear later about the opportunities for engaging with the project, but please remain engaged with us throughout this seminar through the Slido facilities. Now it's time to get into more details about the work that has been done so far in the first year of the project. And for this reason, we will hear about hydrogen awareness and perception practical strategies for public engagement from Dr. Foni von Ruyen, who's the Chief Operating Officer of our partner Institute for Method Innovation Ireland. So Foni, if you are ready, the floor is yours. You have 15 minutes from now. Thank you.
Okay, hi everyone. So I'm Dr. Foni van Rooyen. I'm the Communications Officer for the Institute for Methods Innovation. As part of the HYPOP project, the Institute for Methods Innovation and Environment Park and other partners were commissioned to investigate the current public understanding of hydrogen and fuel cell technologies in the various EU countries. This was done in order to determine the best practical strategies for public engagement on hydrogen energy transport and infrastructure, with the aim of creating co-creation and interactive workshops. So the tasks for this analysis was a secondary analysis of a previously conducted public opinion survey to inform public engagement efforts, as well as an analysis of public engagement with hydrogen technologies on social media across EU 27 countries with a specific focus on the EU 13. So the secondary data analysis was or concerned the Gallup International Public Opinion Survey called Awareness of Hydrogen Technologies, which was initiated and funded by the Clean Hydrogen Partnership. And it's a public opinion survey conducted in autumn 2022 to analyze and assess European citizens' attitudes and knowledge of hydrogen technologies. It used a representative sample of about 26,000 citizens aged 15 and above from all the EU member states, so it is quite representative. The objective was to gain a baseline understanding of public opinion on hydrogen implementation in the EU countries in terms of technology understanding, acceptance, and to inform development of public engagement co-creation workshops. So how we approached this is we did a literature review on the public perceptions and reactions in the EU on hydrogen of various sources and various different public opinion surveys. And then as well, the review and analysis of the Gallup International Survey that I was just speaking about. And then in a deeper analysis of that same opinion survey, we looked at the main individual level determinants of public understanding and acceptance, and then also data that's analytically relevant to the public understanding of hydrogen in the EU. So this chart just shows how the literature review was conducted, initially from 280 records from Google Scholar, as well as hand searches for other sources, which were then screened for relevance. And in the end, we were left with 30 very relevant sources from various journals, journal articles. This is just a snapshot of that. So the overview of those findings from the literature review is there's broad support for hydrogen in the EU, but a lack of detailed understanding and public awareness. In Latvia, Germany, and Poland, public support for hydrogen exists despite a low depth of knowledge. In the Netherlands, cultural predispositions like environmental concern and trust in technology significantly influence support for hydrogen. And there's a universal call for strategic educational campaigns and clear communication on hydrogen's benefits and safety. Local infrastructure projects also face challenges due to the not in my backyard attitude or the NIMBY phenomenon. Spain and Italy showed strong support for hydrogen in public transport, and cautious approaches prevail in Germany and the Netherlands regarding residential hydrogen infrastructure, again due to that NIMBY phenomenon. In Poland and Germany, perceptions vary on hydrogen's reliability and cost effectiveness. There's an increase in European enthusiasm for hydrogen technologies, but concerns about costs and infrastructure persist. And there's some research gaps in Malta and Cyprus and Sweden. So looking at the data in more detail, from this chart, you can see there's a notable trend that more respondents have heard of hydrogen energy than those who have never heard of it. So there's general awareness of hydrogen, but a lack of in-depth knowledge. So there's more that have heard of it, but are not familiar than there are who are familiar with the technology. Looking at some of the charts, this chart shows the role of gender across all of the countries. And what we saw is that while women are nearly as aware as men of hydrogen as an energy source, they feel less acquainted with the specifics. But in other data, we also saw that their support is higher than that of men. When we looked at the role of age, if you can see from the chart, the distribution of ages is fairly similar. So familiarity does not drastically change with age in most countries. And then looking at hydrogen as a good solution for reducing energy dependence, you can see that by far most people agree that it is a good solution for energy dependence. Mostly positive views and broad acceptance in most of the countries. Then hydrogen as a sustainable energy source, again, by far most people show broad acceptance and agreement. When it comes to safety, there's a bit more variability. Western European countries showed higher agreement levels with hydrogen safety than Eastern Europe. And across the countries, you can see some variability, but overall, most people still agree that it is a safe energy source. In terms of seeing hydrogen being as polluting as diesel or gasoline, most people disagreed with that statement, but you can see from the red and the green, there's still some, mixed feelings about that. So then we also did a deeper analysis of the data from the public opinion survey, focusing on key survey questions and using statistical tests like generalized linear models to assess predictive variables. This is to look at predictive variables like age and environmental concern, economic circumstances, etc., to establish a robust framework for identifying demographic and behavioral variables that contribute to public opinions on hydrogen. So the findings from that were that regional influences are minor, but education significantly enhances support for hydrogen. High environmental concern scores were linked to lower awareness of hydrogen's role in transport, heating, and industrial applications. Individuals with high environmental concern scores perceive hydrogen positively in reducing energy dependency and environmental impact. Enhancing the understanding of hydrogen's environmental applications could shape public opinion positively, and social media use currently has limited impact on attitudes towards hydrogen, but we think that is because there has not been a lot of tailored campaigns. So the recommendations from this is to develop and implement education programs tailored to specific regions and demographics, to prioritize educational efforts in countries with lower awareness, to enhance social media's role in spreading accurate information, to address safety concerns, and to emphasize environmental benefits. Then we also did a social media analysis for which we looked at platforms like Facebook, X, Reddit, and YouTube from October 23 to January 24, with weekly searches of keywords, hashtags, and comments and discussions for qualitative and quantitative analysis. So the key findings from that is that there were geographic variability and event-driven peaks. Public interest varied across the EU. Engagement levels were influenced by national policies and initiatives, local events, industry conferences, and government announcements. Socio-political factors also influence perceptions. And in terms of topic-specific interest, public interest in different aspects of hydrogen varies. There is, for instance, a higher interest in the technological aspects, but a lower interest and engagement with infrastructure and policy topics. So the implications from all of these findings are that practical public engagement strategies should deepen understanding of hydrogen fuel cells, vehicles, processes, and technologies in simple terms. It should address misconceptions, economic and safety concerns about hydrogen, such as its reputation for explosiveness and worries over the not in my backyard phenomenon. We should adapt initiatives to fit the demographics and the regional context of each country, ensuring they resonate with diverse European communities. Should actively include women to increase awareness and decrease the gender disparity. We should showcase real-world examples of successful EU hydrogen implementations to demonstrate viability and benefits. Highlight environmental benefits and safety features of hydrogen as a sustainable energy solution. Then also involve industry experts, academics, NGOs, etc., policymakers and such to enrich discussions, to share expertise, and importantly, to increase transparency and trust, because that is very important when communicating technologies. And then the recommendations for social media is to leverage event-driven peaks, such as policy announcements and projects, and communicate accurate information to address knowledge gaps and counter misconceptions. Because transparency is key. Geographic and social political variability requires tailored strategies in the different EU partner countries. Target demographics showing lower awareness. We should emphasize hydrogen's environmental and safety benefits. Collaborate with other organizations and stakeholders to increase reach on social media, and continuously monitor public engagement and sentiment on social media. That's it. Thank you very much. And I think the Q&A will be at the end of the session.
Indeed. Thank you very much, Foni. Since we launched two Slido questions, let's have a look at the results. And if you would like to stay with us just to see what the results are. So the first question was a free question asking, based on your personal experience, which factors mainly influence the public opinion about hydrogen technologies? And this is the word cloud representing the answers that we received. And also in the larger character, we can see the answers which have had more takers than others. And I guess safety issues is one of the issue that, according to our audience, but I guess also according, Foni, to the work that you've done, can come up as one of the factors that influence the public opinion. So more clarity needs perhaps to be done on these issues so that the public is informed. And also we see low or lack of knowledge. And I guess, Foni, you had a similar result from your analysis, isn't it?
Exactly, yes.
Yes, exactly. So any targeted engagement of the citizens needs to make sure that there is a bit more information and evidence-based information on hydrogen to just make sure that people know better about the technology, and also safety issues, safety concerns need to be addressed in a clear manner. So this was the first answer. Let's have a look at the second question. The second question had a more a closed answer, and yes, a closed answer. In this case, we asked our webinars audience whether they heard about public engagement activities with citizens and users. So the experience by our audience is that they have seen training and lessons on hydrogen, and then with a lower frequency, informative sessions, public consultations, but also there is quite a few people who have responded that they never heard anything that was trying to engage the citizens about the questions, and then some communication campaigns and some social media campaigns. So indeed, in our next phase of the project, especially the colleagues from IMI, with the help with all the partners in the project, will we'll make sure that there will be some engagement workshops and with the citizens locally in the local language. And also we will use these workshops to refine some guidelines to support people who want to communicate about hydrogen with the local community, and define some guidelines to help them doing that. So thank you very much for this. Please continue to interact with the Slido facility. You have also have the opportunity to upload your questions. We will be looking at the questions in our break in about 30 minutes. We are now going to speak about social life cycle assessment framework. This is an important tool which we can use to also for informed decision making. And we will hear from Dr. Diego Iribarren, who's the senior researcher at the System Analysis Unit within Fundación IMDEA Energy Spain. Diego, I hope you are ready to share your screen and to start the presentation. Thank you.
Thank you. Thank you, Laria, for the introduction. So I will share my screen. So I will talk about tailoring social life cycle assessment frameworks to hydrogen-related systems and target audience. That is a work carried out in the Systems Analysis Unit of IMDEA Energy within the framework of the HYPOP project. So today in this workshop, we are talking about hydrogen and hydrogen-related systems, and we are talking about hydrogen within the context of an energy transition. So within the context of this energy transition, we have to understand the motivation behind this implementation of hydrogen, and it's quite related to the Sustainable Development Goals from the United Nations. So here we can see, for instance, affordable and clean energy that can be directly related to hydrogen, but this also refers to other dimensions, such as the economic one, when talking about decent work and economic growth. But we can also see that there are many other indicators and goals referring to the social dimension: no poverty, zero hunger, well-being, quality education, gender equality, reducing inequalities. So it's very important to take this aspect into account when talking about hydrogen, because hydrogen has a lot of advantages. It can be applied in many situations across a wide range of sectors. The energy content per mass unit is very high. There is a wide source of feedstocks that can be used, also different energy sources that can be used. When it is combined hydrogen plus oxygen, this leads to water. So that's good because we can avoid carbon emissions. But at the same time, there are some concerns about social acceptance, for instance, as we are discussing today, potentially increased costs, dependence on energy, in particular, potential dependence on electricity. So within this context, it's very important that we identify hotspots and bottlenecks along the hydrogen supply chain and the environmental, economic, and social aspects. So for this reason, the application of the life cycle sustainability assessment methodology is promoted to evaluate the suitability of systems in general, product systems in general, but also particularly hydrogen systems. So this methodology to comprehensively evaluate potential environmental, economic, and social impacts can be understood as a consistent integration of three separate methodologies: environmental life cycle assessment, life cycle costing for the economic dimension, and social life cycle assessment for the evaluation of potential social impacts of product systems. So in this case, I will focus on social life cycle assessments as a methodology supporting the evaluation and communication of potential social impacts of hydrogen-related systems. For those who are not aware of this methodology, I will say that it follows the standardized steps in life cycle assessment, but applied to the social dimension. So these 4 steps include goal and scope definition, where the functional unit of the study and aspects such as the system boundaries are defined. Then the second stage is social life cycle inventory analysis. This social life cycle inventory refers mainly to data acquisition. Then social life cycle impact assessment included the characterization of the system in terms of potential social impacts and risks. And finally, interpretation, including aspects such as main conclusions and identification of hotspots. So within the context of HYPOP, we are adapting this to hydrogen, but taking into account also past initiatives that have addressed social life cycle assessment, specifically in the field of hydrogen. And these 2 of these initiatives are the SHE and EGOS projects that have been carried out within the framework of the Clean Hydrogen Partnership, funded by the Clean Hydrogen Partnership. So, for instance, within the SHE project, social life cycle assessment guidelines for application of the social life cycle assessment methodology specifically to fuel cells and hydrogen systems were provided, and not only social life cycle assessment guidelines, but also their inclusion in life cycle sustainability assessment guidelines. That's something that was taken into account when further developing social life cycle assessment in HYPOP. Also, for the EGOS project addressed the implementation of the social life cycle assessment in the eco-design of hydrogen products. And what about HYPOP? So we have new contributions arising from HYPOP about providing training material for social life cycle assessment addressed to decision makers. That there is a public deliverable provided in July 2024 regarding this topic. So we will have also achieved a milestone in the HYPOP project about FCH tailored social life cycle assessment approach targeted at decision makers. And I would like to highlight the 2 frameworks that were developed in HYPOP. So the first one would be this social life cycle assessment decision-making framework. So this is targeted at decision makers. And here we can see the conventional stages: goal and scope, inventory, impact assessment, and interpretation, including conventional topics such as functional unit, system boundary, but also including aspects learned from previous projects. So for instance, in goal and scope, there is the important addition of materiality assessment to understand, for instance, the stakeholder categories that should be included. For the last social life cycle impact assessment, the evaluation procedure proposed in the EGOS project it was applied. And regarding interpretation, the focus is on social hotspots identification, multi-criteria decisions, and giving rise to recommendations. But the HYPOP project also provided another social life cycle assessment framework oriented towards reporting, and in particular, reporting to citizens. In this case, materiality assessment becomes an optional stage, as we can also implement by default the stakeholder categories defined in the EGOS project, as well as the evaluation procedure as in the previous case. But the main point here when having this new framework for reporting to citizens is that in the interpretation phase, when we are targeting citizens, the visualization of results should be prioritized. So within deliverable 4.1 of the HYPOP project, these frameworks were presented, and for instance, for the one about reporting to citizens, one of the main features is the implementation of the by default social indicators that were based on previous projects, in particular the EGOS project. So regarding sustainable development goals as no poverty and decent work and economic growth, the inclusion of the fair salary category, and specifically the minimum wage indicator. Also regarding good health and well-being, the health and safety category with the health expenditure indicator. Regarding gender equality, we can include topics such as discrimination and indicators such as the gender wage gap. For decent work and economic growth, again, also child labor with the children in employment indicator, forced labor with the frequency of forced labor indicator, and contribution to economic development. Here we can also see a dashboard approach to the visualization of the results for communication of results, expressed here in median risk hours and illustrated for two indicators, children in employment and minimum wage, and also showing how to identify hotspots in a visual way oriented towards citizens. In HYPOP, we are not only proposing methodological frameworks, we are also illustrating these frameworks, and this work is being currently carried out and will be publicly available through a deliverable that will be delivered by March 2025. And in this case, we are addressing case studies both on hydrogen production and on hydrogen use. For hydrogen production, we are addressing a hydrogen refueling station with on-site hydrogen production with a PEM electrolyzer, fed with grid electricity, but mainly PV electricity. For the hydrogen use, we have a case study of bus transport, and including the operation of the bus that can be connected to the previous case with this hydrogen as a fuel, but including also the manufacturing of a PEM fuel cell bus, and including the manufacturing of the PEM fuel cell itself. So finally, to conclude, some take-home messages. Social life cycle assessment frameworks tailored to fuel cells and hydrogen systems have been individually designed to meet the requirements and viewpoints of the intended audience, decision makers and citizens. And there is a recommendation for the integration of these frameworks with LCA and LCC approaches in order to increase the depth and breadth of evaluations. And the benchmarking with relevant case studies is advised for contextual clarity. Benchmarking is always good to understand social results that otherwise, as providing alone the results could make interpretation difficult. And finally, social life cycle assessment is becoming an important approach for the assessment of hydrogen supply chains, but still with a strong potential for improvement, requiring further effort to robustly support decision makers, citizens, and other stakeholders such as policymakers. Thank you all for your attention.
Thank you. Thank you very much, Diego. So we have seen This tool is an important evidence-based tool which can be used to actually evaluate the sustainability of the technologies that are introduced. We have now a question for the audience related to the social life cycle assessment. So the Slido is open and we can see already some movements there. So in your opinion, in which part of the fuel cell and hydrogen supply chain are social risks concentrated? So please, in your experience, try to select where you think that there are the highest risks for society according to the ESG indicators and the indicators that Diego has illustrated. So we will leave this Slido open for a few moments still, so you can have time to respond to it. But we are now moving on the second strand of activity of our project. So we've heard about the citizens, the public acceptance, but we've also worked on trying to understand what is the institutional stakeholders' approach towards the safety, the permitting, and also the certification to some extent of new hydrogen technologies. For this reason, I now invite my colleague, Mattia Miglietta, project manager here in Environment Park, to illustrate the work done so far in project HYPOP, and he will be presenting current safety and permitting approaches for hydrogen technologies integration. Mattia, you have about 10 minutes and the floor is yours. Thank you.
Thank you, Ilaria. Please tell me if you see the screen shared correctly. Yes. So hello everyone, I'm Matteo Miglietta, I'm project manager in Environment Park, and I've been working in HYPOP, specifically in the activity of identification and the mapping of safety permitting and certification approaches for the hydrogen technology integration at EU level. Of course, for the framework of our research, as my colleagues have already shared, is more on mobility residential, and for this part of the activity is more technical, let's say. Also some industry approaches have been analyzed, as hydrogen is thought to be used for different purposes. Nevertheless, as I said, for the purpose of this conference, the current results of safety and permitting have been showed only for residential and mobility, as are the ones emerging sector, because as we know, hydrogen has been used since the last century in the industry sector for the oil refinery, oil and gas, and other attribute industries. But in a more with the high emission CO2 emission related to these processes. So now we are moving toward a hydrogen economy based on low carbon or renewable hydrogen. So again, coming back to our project, we through this research on safety and permitting, we aim to support the EU hydrogen economy through guidances on these topics that will be based on best practices that we are identified at EU level. So just to provide you a picture of the complexity of the different elements that surround the hydrogen value chain, we know that first of all, safety and permitting can take into account different aspects that refer to the different approaches that can be carried out in each country. So, for example, in the safety, we know that there are two different approaches that comes from the knowledge related to hydrogen and hydrogen technologies. It's also related to some cultural, let's say, approach, and we see the performance-based and prescriptive approaches. And as well, permitting is something that is articulates in even more pillars, which are basically summarized as environmental, safety, and special planning issues. So, as I said, hydrogen value chain is influenced by different cross-related elements that you can see represented in this slide. For example, public perception is linked to the institution approaches towards the implementation of hydrogen technologies. And in the same way, a gap on knowledge and regulation as well, still a few number of hydrogen projects, especially implemented in a urban environment, affect the public perception. So I'm quite happy to see that a lot of the keywords appeared in the word cloud actually reflect this slide. And again, the complexity of these correlations are as an unclear regulative framework can bring to also a high variety of project layouts, and this variety of projects emerge in order to overcome or to be compliant to the current or missing legislation. So as you can see, all these elements are cross-related, and institutions we know that play a pivotal role to actually a significant role to support the hydrogen economy. And so, as I said, the HYPOP project aims to provide guidances on safety, permitting, and also certification. And to do so, we have mapped, but we are still interested into understanding and hearing from you about projects and experiences about especially mobility and residential. So here I provide you, I will provide you some examples of such best practices which come from real projects that have been developed at EU level. And for example, here you can see the case of the first hydrogen refueling station built in Italy, in Bolzano, and this project faced some constraints given by the national regulation valid at the time. And then for the scale up of this plant from 350 to 700 bars to be able to refuel not only heavy duty vehicles like trucks, but also to refuel passenger cars, new safety and permitting procedures needed to be followed. So at the moment, the new current national regulation for hydrogen refueling station that has been published after the first implementation and installation of this plant. It presents, it shows some provisions that go, for example, from the need of a containment structure for each hazardous component of the plant, and to, for example, safety distances that, for example, are showed in the table. And as you can see, such a safety distances, it will be hard to be applied within urban environments with a high density of buildings. So to reduce such safety requirements, different elements played a fundamental role. And here you can see how we are summarized. So we know that risk analyses are quite important to interact and engage, especially safety authorities like first responders. So again, the second point is that the interaction with them is fundamental. And as a lot of kind of institutions are involved in the procedures, permitting safety procedures, of course, the explanation of past accidents affecting the hydrogen perception has been important, as well the comparison with other safety approaches around you, which is something also that we want to carry out through HYPOP. And of course, the interaction with permitting authorities for compliancy with the spatial planning have been fundamental. So, staying in the framework of hydrogen mobility, here we provide you an example of another example of, in this case, of a mobile hydrogen refueling station and containerized with a containerized layout. This example is quite important because we know that it shows how the interaction between project developers and institutions can end up with a customized protocol for safety permitting, and in this case also for certification, according, of course, to the characteristics of this project. The main part of this protocol was the development of the technical documentation for this prototype. And this was quite the most complex activity because this documentation related to the consideration of the technical regulation valid at national or local level. And in the case of not available, otherwise, it can be referred to technical standards, industrial guidelines, or other regulation used for other fuels, and they can be considered. And again, for the technical documentation is composed by a development of a maintenance plan, as well the development of a technical documentation for the firefighters, and of course the acceptance from an official engineering association. So once carried out this first part, the prototype has been installed on site, and also the certification aspects has been carried out because such technologies are not quite present in the market. So mainly prototypes are present around Europe, so certification is quite important. And following this protocol, the operation certificate has been obtained from an authorized engineer, and the certification for all the components of this plant been issued by an authorized company, as well a control body has carried out the inspection of this installation. So this example is important to see how is it possible to overcome regulative gaps through customized protocols that, of course, need to take into account the different project features. The second case that I want to show you is related not to a success story, but to a barrier related to the residential sector, where a reversible solid oxide fuel cell for hydrogen production, hydrogen storage, and electricity production through fuel cell for a building have been implemented. Nevertheless, in this case, we don't have a protocol to show you because the project resulted unfeasible to a series of aspects that I will explain you. But the main points that we have represented here is, for example, the ISOP that require the requirement of an ISOP risk analysis required for the safety assessment by the firefighters. As well, it's important to report the interaction with firefighters that have been important to identify the applicable regulations, both for storage and fuel cells. And in the case of fuel cell, we have seen that actually there are not significant barriers for the from a regulative point of view, because fuel cells are considered as a micro-cogeneration system. So once they are defined in the national regulation, actually they have only to fulfill the requirements for the connection to the grid, electric grid and gas network to operate. The issues arise for the storage of hydrogen, which was considered as an hotspot, a safety issue from the firefighters, and moreover, firefighters supported project developers to identify the applicable regulation, because there is a gap in terms of hydrogen storage. And as you can see, the tables represent the safety, again, the safety distances required in the case of a containment of structure used or without the containment structure in the case of the natural gas storage regulation. So the issues again arises because the safety distances are quite complex to be fulfilled in urban areas, and again, also economic issues arises if you want to implement containment structures that are generally made of concrete walls. Well, from an economic point of view, this is quite an issue that in this case hindered the project to be implemented effectively. So another example of the activity that we are doing is to identify guidelines that support institutions and stakeholders in the case of regulatory gaps. And we know that around Europe there are different types of guidelines that can go from permitting guidelines issued by local level, but also at national level. And there are also some guidelines which are more technical and are published by industrial expert association. So this protocol that I have summarized to you comes from a national guideline for hydrogen production projects in Switzerland. And the reason why I show you this is that, as you can see, this is a sketch of this simplified procedure. And the procedure starts with identification of the main permit that is related to the hydrogen project. And once this permit is identified, also the permitting authority must be identified. So then the authority in charge to issue the permit becomes the leading authority of the permitting process. And this is the most interesting part of the procedure, because from now on, this authority leads the procedures and behaves like an entry point that coordinates the activity and the management of all the other authorities that need to be involved for building safety and environmental aspects. So to conclude, of course, further developments are needed. In some cases, hydrogen projects worked and managed to be implemented thanks to flexible procedures, simplified procedures for permitting, common guidelines, and in other cases, instead, didn't work, for example, for a deep regulatory gap, for unclear permitting procedures, and in some cases also for the institution's low attention towards emerging sectors like residential. So HYPOP, to conclude, HYPOP looks for experiences and use cases for mobility and residential sectors. So if you want to put in contact with us, joining our community, to share your opinions, issues and good practice in terms of permitting safety of hydrogen technologies in your country, please, as I said, join in our community and put in contact with us. So thank you for your attention, and yeah, thank you.
Thank you very much. Thank you, Mattia. And indeed, one of the main outputs of Project HYPOP is a set of guidances, documents on what is working best in terms of permitting and safety. We know that there is a lot of work to be done in this area, but by looking at what's already working in the different countries of Europe, then we can actually support the work to improve this situation. Now, let's have a quick look at how Slido has been performing. So if you recall, we have asked you what, based on your personal experience, which kind of barrier have been met during the which part of the fuel cell and hydrogen supply chain is the more risky from the social point of view, and the majority of you has been concentrating on the hydrogen use. So we will see from the work that Diego and IMDEA is doing within our project if this also reflects the assessment. Second, at the same level are hydrogen production, and also it really depends on where you are looking, how far back you are going into the analysis of the study, because of course you can also look at how the raw materials are sourced, which is a sore point. May I take the opportunity also to launch another poll, which we will be looking at at the end of the presentations. Based on your personal experience, which kind of barrier you have met during the process of hydrogen installation, and this is just for us to understand what is your experience in terms of encountering barriers for the safety, for the permitting, or even before that in identifying which are the authorities you need to speak to start the process of permitting. So this concludes the first part of our seminar. We will now give space to colleagues who work with us in Project HYPOP, and who will bring us the experiences in their nation and through other projects about the mobility sector, and also the residential sector and other initiatives which are helping in raising the awareness of hydrogen technology. So I now leave the floor to Maria Panadero, project developer within the Spanish National Center for Fuel Cell and Hydrogen Technologies, CNH2. So Maria, if you would like to share your screen, the floor is yours. Thank you.
Okay, so let me see if you can see it in presentation mode.
Not quite yet. Just switch from presenter to presentation.
Okay. One moment, please.
Yes, no problem. So Maria will talk about the work done by the National Center and Hydrogen Mobility with the example of the Green Island project, which is another Horizon-funded project which looks at the implementation of hydrogen technologies in Spain.
Okay, so now? Or you can see still on the presenter mode.
Still seeing the presenter, the edit mode.
Okay, yes, just 1 second.
Yeah, no problem. After Maria, we will hear from our colleagues from the NGO Balkan Hydrogen Cluster, and then from Bulgaria, and then from Cluster TWID in Belgium. Indeed, Project HYPOP has the brief to look also at what is happening in the EU 13 countries. So these are the countries we've joined later the European Union. Perfect. Maria, we can now see in full screen the presentation. The floor is yours.
Okay, nice. So, hi everyone. Thank you for joining us today, and sorry for the technical issues. My name is Maria Panadero from National Center of Hydrogen in Puerto Llano, Spain. And we carry out different types of projects and activities related to the whole hydrogen value chain. So today we are going to focus on the mobility projects. For example, we are going to, as an example, we are going to see Green Island project, which is a hydrogen valley in the island of Mallorca. We will see some highlights about the permittings and also another examples and another projects about mobility. So regarding Green Island project, as I have said, is a hydrogen valley which aims to develop a fully functional ecosystem in the island of Mallorca, producing the hydrogen in the town of Lloseta through solar energy provided by a PV park. In Lloseta, the hydrogen will be compressed and loaded into a two trailer, and then it will be transported to the different end users. So that leads us to 6 deployment sites, which are the electrolysis plant producing hydrogen in Lloseta, 3 fuel cells producing traducing this hydrogen into electricity and also even heat in a commercial building, which is a hotel, in a municipal building, and in the port of Palma. Also, we blend the hydrogen with natural gas and inject it into the local gas grid. And then we have mobility uses, which consist on buses and cars. So in this case of the mobility uses, we have 5 fuel cell power buses, which are Solaris Urbino and which are already in Palma de Mallorca, and fuel cells powers, fuel cell cars, which will be Toyota Mirai, that will be used by a car rental company. As you may imagine, if we have these vehicles, we need infrastructure to refuel them with hydrogen. So a hydrogen refueling station will be also developed within the frame of this project. So a project of this extent has a really complex complex procedure for permitting and for authorization. So as Matthias said before, this permitting phase often is classified into 3 main pillars: the land use, the environment permitting, and the industrial security. So as an example, for the production of hydrogen, in terms of land use, the regional, the law of urban planning of Balearic Island had to be revised. And also the ordinance, the municipal ordinance in Lloseta had to be followed. This issue is always is many times regulated in a municipal or regional way. So depending on where what soil we want to occupy and the classification of this soil, it will be compatible with our activity or not. In terms of the environmental permitting, we have the European directives that we all know, regulating the environmental impact assessment, strategic environmental assessment, integrated environmental authorization, etc. And Spain has adopted these directives into its national regulation. In turn, Balearic Island has its own regional regulation. For example, the Law 12/2016 of 17 of August regulating the environmental assessment for the Balearic Island. And also the industrial security and the safety and the sustainability must be followed. So other European directives and its adaptations, such as the regulation for low high voltage, the pressure equipment, chemical storage, fire protection, etc., has to be followed. Moving to other part of the project, to the cars and the hydrogen refueling stations, these are still ongoing tasks, so little information can be presented about this concept. In the other side, in contrast, for hydrogen buses, which, as I have said before, they are already in Palma de Mallorca. They have been tested and they have made some trips. The purchase was carried out by tender through the Plataforma de Contratación del Sector Público website. A tender was published with the following requirements show here in the slide. 5 units of buses powered by electric traction with a hydrogen fuel cell with these characteristics and a capacity enough to travel 350 kilometers with a refueling. Having these requirements met, some of the documents that had to be submitted were these: the environmental product declaration in accordance to the product category rules for public and private buses and coaches, the declaration of compliance with the rules for with the European regulation concerning registration, evaluation, authorization and restriction of chemicals, which is REACH, the declaration of responsibility for the procedures and the processes of recycling the components and the parts of the vehicle, ensuring the protection of the environment and of the people, and also a self-declaration of the manufacturer concerning the compliance of the European energy performance certificates criteria applicable to transport. So having this said about Green Island, there are also some other examples of green hydrogen mobility here in CNH2. For example, we have the project FSH2 Rail, funded by the Clean Hydrogen Partnership, which is the entity also funding Green Island. In this project, we are adapting a electric train to a hydrogen train through implementing a fuel cell hybrid power pack. So it's a hybrid train, and this train has already been developed and has already made some trips along Spain and Portugal. So I invite you to search for information about this project. And also in the port sector, we have the H2 Ports project, also funded by Clean Hydrogen Partnership, which consists on developing hydrogen applications in the port of Valencia through the development on three prototypes: a rich taker powered by hydrogen, a yard tractor equipped with fuel cells, and also a mobile hydrogen refueling station which travel from one terminal to another to refuel these two prototypes. And apart from the projects, there are also some initiatives arising for promoting hydrogen. That is the case of the Andalusian guidelines. This is not a project itself, and CNH2 has not been involved with, but we think it's really interesting to showcase this action. This is a document that aims to facilitate the authorization procedure for projects in Andalusia, and it takes into account that regulation for hydrogen are still under development. So for that reason, it in the case of mobility, it explains the different uses of hydrogen in transport. It gives some insight of the different options. It defines some concepts that may be false friends or that may lead to confusion, such as hydrogenera, which is the place where hydrogen is being refueled as well as produced, and hidrolinera, where hydrogen is just being refueled with no hydrogen production. And also it gives some insight into the paperwork involved in the different stages of hydrogen projects, into the production, storage, transport, etc. So, as you have said, this is a really aligned action with realigned with HYPOP project. So we hope to have more actions like this in the future, and to, in the projects itself, produce different guidelines to choose the way for this kind of projects. So that was all from my side. And
Thank you.
I
Thank you
hope
very much. Thank you, Maria. Thanks a lot for your intervention. We are very very short of time now, so I'll go very quickly to our colleague from the Balkan Hydrogen Cluster. So Vasimir Radulov, founder and member of the management board of this NGO based in Sofia, Bulgaria, also chairman of the Hydrogen Energy Cooperative, will present hydrogen, the energy of decarbonization, intelligent hydrogen solutions based on their experience in Bulgaria. So Vasimir, the floor is yours.
Thank you so much. Thank you to everybody. I want to show our practice because in our business we design and produce the hydrogen model electrolyzers. But a few words for our organization. Balkan Hydrogen Cluster is a leader of the hydrogen equipment and the hydrogen technology, and we have more than 70 members, different municipalities, government company, private company in different business fields. We strictly continue on the European political of to implant the green hydrogen in our economic, but we want to show one of our model. This is for short. This is our technology for one of electrolyzers. This is alkaline electrolyzers, which produce pure hydrogen. And do you hear me?
Yes, Vasimir, we can hear you. We are just not seeing the presentation in full mode. Thank you.
I share the screen. Can you see our presentation?
Not just yet.
One moment.
And just while Vasimir is sorting out the presentation, hopefully we will be able to cover also our last presentation from the colleagues from TWID. We have collected your questions. Thank you,
Now,
Vasimir. You can
you see? Can you see
Yes,
now?
yes, perfect. Thank you.
Okay, okay. I'm so sorry. And this is our short presentation, our mission, our vision, our goals and solutions for different hydrogen needs of our member and clients. We are the biggest hydrogen association in Balkans, and that's why we want to show our few of our technology. I show one of our model electrolyzer systems. This is alkaline electrolyzers. I will tell you later why I show this picture, because we want to show that we finish more than 40 projects in Bulgaria in different fields, because as I said, we design and produce this equipment. We finish more than 40 projects in a different economy fields. We believe that with several and numbers of small completely project, we can show the real step-by-step roads, how electrolyzers, how green hydrogen show our way for decarbonization economic. That's why we produce this different model for different needs, because more of the our building and our different economic our members have different needs. That's why we don't want to put the big electrolyzers. We want to put exactly for their needs, and we produce step by step. We design, we discuss with our client, and we finish more than 40 different projects. And for the business, it's good because we make every month we make forums, we make opening meetings with the business, with the government, and we discuss how electrolyzers, how green hydrogen, how this new green energy is good for the business, is good for climate. And we every day we see that our citizen, our society, and our partner have a good look for the hydrogen, because in the past, when we start to talk for the hydrogen, everybody think for a hydrogen bomb. Nowadays, after 5 years hard work, when you start to talk for the hydrogen, they know our organization very well, and they know that the hydrogen is the new wave of the green energy. And because our equipment is certified, and we have all safety standard, we put them in a different, as I said, in a different building, in the public building, in the school or kindergarten, and the university, and we have a big economic effect, because with our equipment we have more than 25% economy of the hydrocarbon fuels. because the hydrogen is very good to make mixed with the like our example with the natural gas, and we have a very good example and very good number of economic effect. We every of our project we have oversights of them, and we worked for to put how can I say, like um, um, overview of every of our client, because we want to know in each of them in every moment how electrolyzers work and how green hydrogen make the mixed and to make this good economy. In our example, we you can see that we show that in one boiler in Visman, we in option A, we the boiler working only with gas, and option B, we put our equipment, and with this hydrogen oxygen fuels, we combine with the gas, and we have a good result of our client, because that in Balkans Peninsula it's a very different fuels to make hydrogen political way to put this equipment. That's why we make a model step by step to put in a different building, in a different economy fields, because we believe that the decarbonization goes hand by hand with introducing the hydrogen technologies. And we are private to say that we design the first 3 hydrogen valley in Bulgaria, and we want to tell that we designed one. The first one in Balkans produced for green ammonia, because the green ammonia is the main material for the decarbonization, and we design this project, and with our equipment and our good history, we can show that the hydrogen is good for a business, is good for the citizen, it's good for transport, and good for our idea for European Commission for decarbonization of economic, and because our partner is a different university, as I told you in the beginning of our presentation. This year, we in Bulgaria opened the first charging station for hydrogen. This is for open for every of our citizen. It's good to show how it's work, because till this year nobody know how this charging station will be put and will work. Nowadays, everybody in Sofia know that we have the first charging station of hydrogen, and everybody know that hydrogen is new energy and new fuels of the transport, of the electricity, of the public building for heating power, and we know that we walk for a right way, and step by step with our partner we show the good practice, and we show our efficiency and our good way to show of the people how hydrogen, green hydrogen, work for them. Thank you.
Thank you very much, Vladimir. Sorry to have cut short this presentation. You will, in any case, find the material onto the Sustainable Places conference website, so that will be made available to you. So we can quickly go to the last of our presentation, and is an experience from the Belgian point of view. So Simon Habron, project engineer from the cluster TWID, will explain us how companies, universities, and public entities are key to raising public awareness.
Yeah. Yes.
Yes, thank you very much.
So good morning, everybody, and bon appetit for those who are hungry and start their lunch. So yes, just to introduce myself, I work for Cluster TWID. So Cluster TWID, we are an association to promote all renewable technology. We have clustered these different topics in different ecosystem, and one of this ecosystem is HYPOP. So I'm responsible for this ecosystem, and I have written my contact in this slide. So this ecosystem is called H2UP, and of course we are in this ecosystem since HYPOP is on hydrogen technology. And for my presentation, I will try to make the link between cluster, because cluster we are more oriented about industry and universities. So make the link between these entities and the public awareness. So the answer of this link is on my title. So I think companies, university, and more globally, research, education, training infrastructure are key to raise, to improve public awareness, because companies will develop this new market. And if we want that the citizens accept this market, they must see this new market. For the education training point of view, we will need new courses, new training to develop this new sector. So this will improve awareness of students. And the public entities are very important also to develop this new sector, because if we want to move in this new hydrogen market, we must have the target zero accident, because if there is some accident in Europe, it will be very difficult to develop this market, and think one accident can just kill the market. And so the cluster are very important to make the collaboration between these three entities. For example, companies need new competencies, so there will be exchange between research center and education center and companies. And of course, public entities are really important to make the new rules, to make subsidies, tax incentive, penalties to help or force companies to enter this new market. So I will enter in the easy example of in fact, Cluster TWID is in Wallonia region. So Wallonia is in Belgium, but Cluster TWID, we have associated our force with the Flanders region, and we have created the Belgium Hydrogen Council. So I have also a part in this Belgium entity. So here is the value chain in Wallonia. So this is all our members that are active in hydrogen, and we have placed in the different sectors. So you can see that there is a lot of member in technology and engineering and integration, and there is a lot of actor also in innovations. So this is a good thing, because when there is a new sector, it's really important that we have a lot of actor on this field. So if we focus now on companies, So Belgium is really well known for its beer and French fries, and so the two first projects, Walico and H2C Mukron, is on this topic because Walico is for trucks that will deliver beer. So there will be H2 production by water electrolysis. So thanks to wind and photovoltaic panel. And this green hydrogen will be used to refuel trucks. The other one is we will produce electricity thanks to the waste of potatoes, and so this green electricity will be converted in hydrogen, and this hydrogen will refuel trucks for the waste of the citizen. And the third one is more traditional. So it's hydrogen. Green hydrogen will be produced by wind and photovoltaic panel, and it's also to refuel trucks. So another project is so John Cockrell is very well known for his electrolysis. So he wants to build a gigafactory. So it's to build production of electrolysis. So Project Columbus is for lime production. So it's to combine the CO2. So it's CO2 capture, and it would be combined with hydrogen to make some e-methane. And the two last one is for very heavy transport. So IPSA it's to develop hydrogen propulsion for aviation, and ZELI is for the use of green hydrogen for the ship. So there is some projects in Wallonia, but clearly difficult to come from project to real case and to finish the project because of different things. But there's one with the permitting and unclear safety measurements. So we have already talked about this issue with the HYPOP project. So we will work on this topic in HYPOP project, and Mattia have presented how we will do it and how we have already done it. And the second thing is also for the bad business cases. Because of green hydrogen is quite expensive, so there is a need of CapEx and OpEx support from the government. And also to have a better business cases, you have to scale up the project. So you have seen that there is like individual project, and so if you want to be a better business case, you have to scale up the projects, and so maybe gather different projects together. And one solution is to develop a hydrogen valley, like in Spain. And so there is an ambition in Wallonia to develop this hydrogen valley. So you can see on the map that there is two clusters, so two city centers that are very active on hydrogen. And the idea maybe it's to combine these two cities or to develop a hydrogen valley in these two cities. And in Wallonia, our strength is industry decarbonization. There is a big potential for green hydrogen, and also the mobility, because there is a lot of trucks that